Hello everyone, and in this video I'd like to talk about the process of expiration. So what happens when we breathe out? And here is a picture of the lungs right over here. And as I discussed last time, we have the visceral pleura attached to the lungs, the parietal pleura in blue, and the pleural space or pleural cavity in between, which contains pleural fluid, preventing the two surfaces from rubbing against each other. We also have lymphatics to drain the extra fluid from the intrapleural space, preventing that fluid from pushing on the lungs. And so, as you can see here, I put an arrow with air rushing out because that's what expiration is. When you exhale, the CO2 comes out. And for this to happen, we need to have some sort of pressure gradient. So as we mentioned last time with the process of breathing in, whenever we breathed in, we had signals coming down to the medulla and also from the cerebral cortex down to the cervical and thoracic spine, which then led to the production of the phrenic nerve, shown in green, which innervates the diaphragm. Let me actually write this down here. So this here is the phrenic nerve. And then we also had the intercostal nerves, right? Here we have a synapse at the anterior gray horn of T1 to T11, and this would give rise, the lower motor neuron would be the intercostal nerve, right? So axons coming from here will give rise to the intercostal nerve, whereas axons coming from the right after you synapse here at the cervical vertebrae between C3 and C5 in the cervical region, the axons that come out will form the phrenic nerve. Okay, so this is important to consider because these nerves are going to innervate the diaphragm and the external intercostals to lead to respiration, specifically inhalation, breathing in. And we talked about it last time that these muscles are going to increase the thoracic cavity volume, right? And as the chest wall expands and the diaphragm moves out, the parietal pleura moves along with it, and the volume here goes up. So we get a higher volume, but the pressure went down. In fact, the pressure went down, if you recall, all the way to -6 during quiet breathing, and even as low as -7 during active inhalation. And this negative pressure allowed the lungs to expand as well, because remember, they're attached to the parietal pleura. The space is only a potential space. So as the parietal pleura moves out, so does the visceral pleura, and also the negative pressure, right, allows the lung to further inflate, and so the volume in here goes up and the pressure then goes down. And if you recall, the pressure went down to -1 during quiet breathing and even -2 during active breathing, and this allowed a pressure gradient because if you recall, atmospheric pressure was 0, so the pressure gradient allowed the air to move out from the lungs to the atmosphere until the pressures are equal on both sides. So let me just erase that. Moreover, if you recall, we had the bucket handle and the pump handle. So when the ribs move up and out due to the contraction of the external intercostals, that was similar to the bucket handle. And then when the sternum elevates due to the contraction of the external intercostal muscles, this is like the pump handle. Okay? And as we'll see in the process of exhalation, this will just be reversed. Now, let me just explain that there is a process called the Herring-Brewer reflex. So essentially what happens is when the lungs are inflated, or as they're inflating, there are stretch receptors which detect that. And these stretch receptors are located in the smooth muscle of the lungs. And these stretch receptors are going to send signals, inhibitory signals, to the ventral respiratory group of the medulla. And they're going to cause inhibition. And so this is going to lead to a lower frequency of action potential down the spine. And thus, less action potential frequency going down through the phrenic nerve and less action potential frequency is going to go towards the intercostal muscles via the intercostal nerve. So because there's less action potential going through these nerves, the phrenic and the intercostal nerve, there's going to be less stimulation to the diaphragm and the intercostal muscles. And what this is going to do is it's going to cause these muscles to relax. So as this happens, there's going to be less innervation of the external intercostals and the diaphragm, causing these muscles to relax. So the muscles that were contracting in inspiration now relax during expiration. But when we were inhaling, the ribs moved up and out. But when we're breathing out, the ribs move down and in. Also, because the external intercostals now relax, the sternum depresses. It moves inferiorly. And this is like the reverse, right, of the pump handle. Okay? Whereas the ribs moving down and in is essentially the reverse of the bucket handle. The arrow is now in the opposite direction. Okay? So what this will do, it will cause the parietal pleura to move more inwards. Okay? So the parietal pleura is going to move more inwards as it's attached to the chest wall. So because you're decreasing the thoracic volume as the ribs move inferiorly and medially, and the sternum moves down, and by the way, there's also less stimulation going to the diaphragm. So this is going to cause the diaphragm to dome and round up. It's going to cause the diaphragm to relax and dome up, to round up. So it's going to go up. And again, this is also going to decrease the thoracic volume, specifically in the superior-inferior direction. So overall, we have a decrease in the thoracic volume. So what happens now is as the thoracic volume goes down, this will cause the parietal pleura to move with the chest wall, and therefore the space here will decrease. So the volume will decrease. And as the volume decreases, the pressure here will go up. Okay? And as the intrapleural pressure goes up, it becomes less negative. If you recall, during quiet breathing, during quiet inspiration, it was -6. Well, now it may go up to, let's say, around -4. And as the pressure here becomes more positive, you can think of it, it's going to push on the lungs. So the lungs are also going to go in, right? And as I mentioned, as the parietal pleura goes inwards, as you can see here, because it moves along with the chest wall, the two are connected. So because this is just a potential space, so therefore, as we mentioned, the pressure here would go up, and that's going to push on the lungs. So the lungs would collapse inwards as well, right? The visceral pleura would go inwards as well. And so the pressure in the lungs would increase as well. Now, the pressure in the lungs, we call this the pulmonary pressure, is going to go up to approximately +1. And because of that, there's now a pressure gradient, which is going to drive the CO2 out of the lungs. And the CO2 would move out until the pressure in the lungs is equal to the atmospheric pressure. So now you have this pressure gradient that allows air to move out. Okay? So this is during quiet exhalation. Remember, we said that intrapulmonary pressure was about -4. Sorry, the intrapleural pressure was -4. The pulmonary pressure was +1. And then we had the chest wall moving inwards, pushing on the parietal pleura, and the pressure here becoming more positive, pushed on the lungs, increasing the intrapulmonary pressure, so air moves out of the lungs. Now, what else happens during the process of quiet breathing? So when we breathe out quietly or passively, what happens is the lungs recoil. So there's elastic recoil of the lungs. So the lungs have a tendency to collapse. So as we stretch them, they want to get back to their they want to go back to their original size. So this will also cause a collapsing force here to decrease the space inside of the lungs. So in addition to the intrapleural space becoming more positive, pushing on the lungs, also the lungs want to naturally collapse due to the elastic recoil. This is a passive process because it requires no energy. Okay? Another thing that we have here is that the joints go back to neutral. So we'll talk about the joints that are involved in the rib cage moving, and so they just go back to their anatomical position, back to their original state. Okay? And the last thing that happens, as I already mentioned, is the diaphragm plus external intercostals relax. Okay? So this is really, really important to understand. The next thing I wanted to talk about is the process of active breathing. So let's look at active breathing here. So active breathing. or in this case, active exhalation, right? So active, let's put breathing out. In this process, what happens is we have the usage of abdominal muscles. So the abdominal muscles are going to be put to work. And these abdominal muscles are going to push up on the diaphragm. So increase in abdominal pressure, right, because these muscles squeeze and contract, it's going to push up further on the already relaxed diaphragm. So that's going to decrease the thoracic cavity volume even further, because these abdominal muscles are going to push up and back on the diaphragm, and that's going to cause the thoracic volume to decrease. Another thing that's going to happen is there's also going to be additional muscles, and these are known as the internal and innermost intercostal muscles. Remember how I told you there are these muscles between the ribs? We call them intercostal muscles. So we use the external intercostal muscles for quiet breathing. In fact, they relax during expiration, during exhalation. But there are also other muscles between the ribs that are used for exhalation, specifically forceful exhalation. And these are the internal and innermost intercostal muscles. So these are also intercostal muscles. Okay? And these muscles here actually insert on the inferior aspect of the rib above. So they help yank the ribs down. So these muscles are going to cause the ribs to move down and in. Down and in. And that's going to decrease the thoracic volume in the left and right direction. Whereas the abdominal muscles push up on the diaphragm, right? They cause it to round up or dome up. And that's going to decrease the thoracic volume in the superior inferior direction. So again, we have a decrease in the thoracic volume even further. So on this side of a lung, I'm going to do what happens during active exhalation. The volume goes down even further, and therefore the pressure is going to go up. And as the pressure goes up, it's going to push on the visceral pleura, and it's going to collapse the lungs even further. So the pressure in the intrapleural space is going to go down to around -3. So it's going to become more positive. And what this is going to do is it's going to push further in onto the lungs. It's going to push on the lungs further. So the pressure inside of the lungs, the intrapulmonary or intraalveolar pressure, people, is going to go up even further to +2. It's going to increase to +2. During quiet exhalation, it was +1, but now it's +2. You know there's an equation, and this equation is flow is proportional to the change in pressure over resistance. So if there's a bigger delta P, there's going to be more flow. So in this case, more air is going to rush out. And this is important in situations where you're exercising, where you need more oxygen. But in order to get more oxygen, you need to breathe out all the waste, all the CO2 out. So there's a bigger pressure gradient, so more oxygen is going to go out until the pressures equalize between the lungs and the atmosphere. until the intrapulmonary pressure is equal to the atmospheric or barometric pressure. Okay? So this is something I wanted to point out. It's extremely important. This is the process of forced expiration. It involves the abdominal muscles, such as the oblique muscles, right, which play a big role, as well as the rectus abdominalis. And these muscles actually push up on the diaphragm to decrease the thoracic volume. And then we also have the intercostal muscles, specifically the internal and innermost. They're going to yank down on the ribs. They're going to pull down on the ribs to move the ribs down and in, and that's going to decrease the thoracic volume in the left-right direction. So overall, you have a decrease in the thoracic volume. So the chest wall is gonna decrease in size. It's gonna pull the parietal pleura with it. The intrapleural cavity, the volume there is gonna decrease. According to Boyle's law, the pressure will go up approximately to -3, and that's gonna push on the lungs further to collapse it even more, in addition to the forces that we discussed in quiet expiration, such as the elastic recoil and the relaxation of the diaphragm and the external intercostal muscles. So now we have a situation where you have additional muscle recruitment. In fact, passive exhalation involves no muscles, specifically no muscle contraction, whereas in active exhalation, you need to contract muscles. In passive exhalation, we just had the relaxation of muscles, but in active exhalation, we need to recruit additional muscles, such as the abdominal muscles, such as the oblique muscles and the rectus abdominalis, as well as the innermost and internal intercostal muscles between the ribs, to further decrease the thoracic volume. And as the thoracic volume decreases, the pressure goes up, right? And there's a higher pressure within the lungs. The pulmonary pressure goes up, increasing the gradient between the lungs and the atmosphere, so more air can rush out. As we already mentioned, there's a bigger pressure gradient, so therefore there will be more flow from the lungs out into the atmosphere.